Right, 2019, section C, part 3. Just give me 2 seconds here now, I just want to upload our video. Keep the ball rolling. Right, so the image on the right shows the Louis Vuitton retail store in Singapore. Design comprises a steel frame glass building with irregular shaped faces. Figure C3 shows the elevation plan and end view of a model of part of the building. Draw the given elevation plan and end view. Is part A. Right, let's go into that first. Okay. So I'm going to start by setting up my XY line. Press there. And I'm going to keep this, try and keep it roughly in the middle of the page. So I'm going to start this bottom corner here, about here. Okay, so scale is 1 to 100. Okay, so we can divide all of them by 100, so that's 2 meters. So that's going to be 20 millimeters in my drawing here. 75, 2.5, and 3.5. Okay, there are my horizontal distances. So I'm going to draw them up and down. Drop this one straight down. This one has to be straight down. This one will go up and down. And this one is straight down. Okay, heights here in my elevation and my end view, I'm given at 6. I'm also given 3.5. Okay, so I'm just going to heavy in my elevation there first. C is here then. That should be a light line there. Not bad. I'm drawing my end view here as well. I'll finish that off there in a second actually. I'm just going to bring this down here to give me a starting point. So it's 2. It's actually 10 really gap between them. I don't have too much. It's going to be 2. 3 meters, which is 5. 7.5. Hope this fits in the page now. Should do. As I said before, you'll have big pages in the exam. It's just I obviously don't have big pages here at home. Right, we'll just heavy this guy in then as well. Don't know what that pen. This goes to here. This goes there. one across the back. I'm not sure what that one is. But I can get it by bringing down my 6 meters here. And where the 6 meters hits that point there, gives me this point. And that zooms back in there. Finish up that bit there. This is coming down from my elevation. Right there then goes back to here. This is broken. Now I can check up all my widths then for my plan. I'm straight up now, and then just go back and heavy in. So just it takes a bit of figuring out now where to position all these bits. That's A there. And that's running down to the ground here, which is this line. So I'm guessing that's A there. And the B is that height there. Comes across and hits it there. Is it there? No, it's this height here. Fairly tricky one this now. Fairly tricky setup. Right there, comes down, comes up. This is this out here. It's going to come up there. Across here. And this then comes back down to so this point here is coming down to there, comes down here, it's this fella, come up there. Lovely. That's my elevation and plan set up anyway. elevation plan view, sorry. Determine the dihedral angle between surfaces A and B. Okay, so from our planes question, how do we get the dihedral angle? Well, what we do is we get a true shape, or sorry, a true length of the line of intersection. True length of the line of intersection. So my line of intersection is where now? It's between A and B. This is surface A here. A. Now this is our tricky bit, look. A looks like it's this big surface here, and it's there, that's B, so it looks like it's this line, but it's actually not. A is only this little surface here, and this is B out here. So that guy there is our line of intersection, that fella there, and that fella there. So what I'm going to do is I'm going to take, doesn't matter which way I take it from, so I'm going to take it from my elevation here. So set up, so this is my line of intersection here, okay? Set up about 90 degrees, sorry, should be light. Set up an XY line, X1, Y1, and take up my points. So I'm going to take up my heights here. So I'm taking the distance from the XY line down to the plane here. So that's 1 point there. And then my other true length line is out here. So that's my true length line there. Now, what will I do? I'll label these 1, 2, 3, 4. And then 5 and 6. So my true length line is 4 and 3. So what I need to do now is I need to get 1 and 2 and bring them out. That's 1 is actually up there as well, and 2 is down here. 5 is here, 6 is here, and 4 and 3 are obviously there as well. 4 and 3. Okay. So I know 1 and 2 are actually 1 and 2 are out only 10 mil. Because that's the distance between there and there. So I'm going to tip that. 5 and 6 then. I actually have to project out 5 and 6 first. The distance then from XY into the plane is 5. Sorry, that's not right. That's 5 there. Just be careful, so it's from the XY line to the point. And 6. 5, 6. They can all join back then, so 5 and 6, 1 and 2, 1 So what do then? So I have my true length line. I want to look along my true length line. Along the true length line. So parallel. And bring out these. Six, 5, and 2. So then take the distances from the view just back. So distance from 1 there. I'll foreshorten these. So I'm going to use this line here because this is parallel to X line, just to bring it back. So that's 1, that's 2, 4 and 3 is there, and then 5 and 6. I need one of them already. So 5, just put there, extend that down. That's 5 there, so that goes back there. That's the dihedral angle between A and B. Okay. Dihedral angle. That's part B done. Part C, determine the true shape of the vertical surface C and the true shape of the inclined surface B. Okay, so we want the true shape of the surface B, which is here. The true shape of surface here, which is there. So the true shape of surface C, we'll go with that first. So how will I get true shape? Well, if you can imagine, that's what it is currently. So it's up there, it's standing up like that. If I catch that and flatten it out over here, I can get the true shape of it. So if I go perpendicular to that line, take out those points there. I'm going to go up to my elevation, I'm going to take my height. So that's where 6 is. That's where that point is. I'm going to go up and take this measurement here. Step it up. I'm going to take this measurement here. Step it up because this is the vertical height. So that's the height and elevation. This is the width and plan. I'm just projecting out my widths here and stepping off the heights on them. That's the true shape of surface C there. We do the same for B then. Project out. I don't have any, don't need to project out the base, but I'll project out here. Put the edge there, the vertical edge, top edge. That's the base. And the far edge. Bring it down. Again, take the heights. This is on the ground. This is on the ground. There is 2 things I can do here now. I can extend that line there. I can take the height that we have in elevation here, bring it down, step it out there. Same on this side, take the height there and step it out there and join it back. Or the other thing I can do is I can take the width, the length of it there, so that edge there is the true length of that edge already. I can stick it in there and I can swing it. That should work now. And same, I have the true length up here. Maybe I have to get the true length some. I would have thought I would went out the height. That's not true width. Yeah, so that's actually not a true width there. So what we have to do is we have to get the true length of this edge and this edge. We found the true length of this edge already. It's over here. So I'm going to take that, swing it off, step it up onto the side. We found the true length of this edge over here, which is my intersection line, which is this guy here. So I can take that distance there. And I can step it off out there. Outside of them then, I can join them back. And that's B. Okay, so you have to get the true lengths of the edges because they're actually, that's an angle line there and that's an angle line there. Okay, the last part of this question then is determine the horizontal and vertical traces of the surface B. Okay, so the traces are where this cuts the ground line, okay? So I just using my protractor here, it's a flat plane where it shows where it cuts my horizontal and vertical trace. Now I know that this guy here is already on the ground, so this line here cuts the ground. So this is my horizontal trace gone out there. Now it kind of goes off the board. We won't worry too much about that. Can you see that? Yep, it goes off the board marginally, but you can still see it. Okay, how do I get, now that I have the horizontal trace, HT is off out there, how do I get the vertical trace? Well, I know if I project parallel to my trace through a point, so I'm going to go through 2.5 here, bring it across, bring that straight up, and take the height of 0.5 across here. Boom. That's 1 point on my vertical trace. And I can then join that back to my horizontal trace, which is on the ground there. And I'm going to draw it just outside there. And that's my VTH. If you did happen to run out of space in the exam, what you can do is just get another sheet and tape it into the side there like that. And you can draw it that. Alright, so that's that full question done. Any questions, post them to me and we'll sort them out.